Hi everyone. Today we're going to talk about real-world quantities, and the way we're going to do this is through a couple of example problems to recognize how we can come up with our own formulas for certain scenarios. What you're definitely going to want to do is print out your foldable, and this is a kind of fortune teller style foldable where you're going to cut out the square and then fold the corners towards the center to create a diamond. And each problem in this scenario is really important because it helps you to write an equation to model the example. So if you have any questions, please be prepared in Friday during the beginning of class to ask them and to share them with the class. Problem number 1 asks us, the perimeter of a rectangle is 64 feet. If the width is 4 feet, what is the length? Well, we all know that perimeter is equal to 2 times the length plus the width. Now there's a variety of ways to write this. We could also write perimeter equals 2 times the length plus 2 times the width, or we could say perimeter equals length plus width plus width. It's up to you. I feel like the distributive property is most useful here because 2 is being multiplied by both the length and the width. So to put the 2 on the outside of the parentheses kind of saves you some interesting notation. So if I know perimeter is 2 times the length plus the width, I can start substituting in numbers that I'm given in this problem. Right now it tells me the perimeter is 64 feet. So I can plug in a 64 where I put that P for perimeter. 64 equals 2 times length plus width. Well, guess what? It also tells me that the width is 4 feet. So where I have a width, I can plug in 4 feet. 64 equals 2 times length plus 4. The question asks, what is the length? At this point, I'm not quite sure because I haven't distributed, but let's do that. 2 times L is 2 L's plus 2 times 4 is 8. And don't forget, that's all going to equal to 64. So what this problem is telling me right now is that 64 is equal to 2 times some number plus 8. So I'm going to work backwards a little bit, and I'm going to think to myself, well, if I'm adding 8 to my 2L, if I take that 8 away from both sides, it'll help me get closer to figuring out what number is equal to just 2 times the length. So 8 minus 8 is 0. 64 minus 8 is 56. So 56 equals 2 times the length. Well, I don't need to know what 2 times the length is. I just need to know what the length is. So I'm going to divide both sides by 2, and I should get the value for one length. 56 divided by 2 equals 28. 2 divided by 2 equals 1. So I have 1 L. 28 is equal to the length. I can go back and actually check my work pretty simply by looking at the formula that I wrote that has all the substitutions except the L and actually plugging the L in. So 64 equals 2 times, this should be a 28, plus 4. So let's see how that works. 64 equals 2 times 28 plus 4. So I'm going to distribute. 2 times 28 is equal to 56 plus 2 times 4 is 8. 56 plus 8 is 64, which is what it's supposed to be. So I know that I got the correct answer. Problem number 2 says Candice works 40 hours per week. She receives a paycheck of $960 every 2 weeks. How much does she get paid per hour? So if Candice works 40 hours per week, but she gets paid every 2 weeks, then 40 hours times 2 would be 80 total hours. I want to know how much money she makes per hour, and that should equal $960 total. So over the course of 80 hours, how much is she making per hour to get a total of $960. I can solve this easily by dividing. Divide both sides by 80. So the amount of money she gets paid, X, should be equal to 960 divided by 80. And you can do this out longhand. This isn't a difficult problem. It is $12 an hour. So again, if I go back and check, if Candice gets paid $12 an hour and she works 80 hours over the course of 2 weeks, well, that's going to give me a total of $960, which is what I was told she's paid over the course of 2 weeks. So I know that my answer is correct. The nice thing about these equations is that if you go back and plug in your answers, you can always double check to see if you're getting the right solution. As long as your initial equation is correct, you shouldn't have a problem. Number 3 says Larry needs to buy 5 books at the same price. After he uses a $30 gift card, he can spend no more than $50. What's the maximum cost of each book that he can buy? Well, he already uses $30, and he doesn't want to spend any more than $50, so that's a total of $80. 30 plus 50 equals 80. But he's buying 5 books, and they should all be the same price. So 80 divided by 5 is going to be the price of each book. The maximum cost of each book, 80 divided by 5, is equal to $16. Number 4, and our last problem, Lola wants to purchase a pair of shoes for $20. She also wants some socks that cost $4 each. She only has $35 to spend. How many pairs of socks can she buy along with the shoes? Well, the shoes we know are $20, and we're going to combine those with the cost of the socks, and we're going to multiply that times the number of pairs of socks, which seems a little silly. That cannot equal more than $35. Excuse me. So $20 plus $4 times each pair of socks equals $35. That seems like a pretty standard equation for me. But I need to know how many pairs of socks that she can actually buy. So first of all, I'm going to remove the $20 that she spends on the shoes from the purchasing side of my equation and from the cost side of my equation. 20 minus 20 is 0. So that leaves me with 4 times the number of socks that she wants to buy equals $15. So I know no matter how many pairs of socks she wants to buy, she only has $15 to spend on them. Also, if they're $4 each, I divide by 4, and I can get the pairs of socks that she could buy. 15 divided by 4 is a little tricky. It's not an exact number, so I'm going to do it as long division. 4 goes into 15 3 times. 3 times 4 is 12, and when I subtract, I get a 3. And I could bring down a 0 if I want and add a decimal point. So 4 goes into 30 7 times. So Lola could buy 3.7 pairs of socks, but since you can't buy 0.7 pairs of socks in the store, the most socks that she can buy is going to be 3 pairs. Remember, you could round your solution, but you're not going to round up because you don't have enough money to round up for another whole pair of socks. It's important to make sure that you're practicing your proof problems. So be sure to complete that. Number 2 says, Kelly buys shoes with all her money. She only has $150. 1 pair of shoes for her, and they cost $40. The other 2 pairs of shoes are for her sisters. Each of the pairs of shoes costs the same price. Determine the price of 1 pair of shoes. So you're going to want to write an equation, and then you're going to want to solve it to figure out what the price of 1 pair of shoes is. Try not to do this problem without writing an equation. I know it's possible. However, there are going to be problems that come up that are more difficult that you're not going to be able to do without having an equation for. So we want to start practicing now.